So let's start with the hybridization. What is hybridization? So hybridization is the mixing of the atomic orbital to a new kind of orbital. Especially carbon can do that kind of property. So it totally depends on, like, if you understand the electronic structure or electronic configuration of the carbon, then you will understand like how hybridization happening. So let's see what is the carbon electronic configuration. So carbon has a total 6 electron, and it can be saying 1s2, 2s2, 2px1, 2py1, 2pz0, because total 6 electrons. So here it has 2 unpaired electron. That's why sometimes carbon can show the valency is 2, but maximum time carbon show the valency is 4. How? So in excited state, we can show that carbon has excited state. So in excited state, first shell electron is okay, but in second shell electron, the 2s electron goes to the 2pz. One of the electron goes to the 2pz to make like p orbital full, because normally the p orbital has 3. One is x, px, py, and pz. So normally they can stay like with the electron with the half field or the full field. So since one p orbital is empty, like 0, that's why it will take one electron from this s orbital. So in that case, we can say 2s1, 2px1, 2py1, 2pz1. So the outer shell now showing like all 4 unpaired electron. That's why carbon can show 4 valency, because of the number of unpaired electron. Now carbon can do like 3 types of hybridization. One is called Sp3, another is Sp2, another is Sp. So let's see what is the Sp3 hybridization. So when one s orbital, like 2s and 2px, 2py, and 2pz. So when one s orbital and 3p orbital all together mix together, and like you can think of, suppose it made a like something like a dough, and then it will it will divide it in equal amount. Like how many orbital is mixing? Total 4. So that 4 orbital mixed together, and it will give you a new kind of 4 orbital, which are equal energy, and also each orbital had 1 electron. So after making like hybridization or mixing of those electron, each new orbital will have 1 electron, unpaired electron. So all of those together is called Sp3 orbital. Sp3 orbital. So because 1 s orbital and 3 p orbital, that's why it is called Sp3 orbital. Now in each Sp3 orbital, you can think about the how much s character and how much p character. So total 4 orbital, 1 is s, like so 1 s in a total 4 orbital. So you can easily think like s character is like 25% and p character is 75%, because there are 3 p orbitals. So each orbital of this sp3, so 25% s, 75% p, 25% s, 75% p, 25% s, 75% p. Same for this one too, like 25% s and 75% p. So this is called sp3 hybridization, because one s orbital 3p orbital mixed together. You can take an example, like suppose you are taking some sugar and like totally different property, and some rice, and those rice are totally different property. So you mix together, boil together, and then you put it in a container like this, and then you take like four different source, like four of them. So you just equally distributed that sugar mixed rice, boiled soup type things. So in that case, like all soup will be the same properties, similar thing, but equally distributed. That's the real example you can think of for the sp3 hybridization. So the sp3 hybridization, now we can think like how actually carbon shows that bond and how it forming and what are the properties. So if you think like carbon, and it takes like it produce new bond, four bond, so each has one single electron in this hybridized orbital. So we can say it is sp3, it is sp3, and it is sp3, and it is also sp3. Now when one hydrogen overlap with this like you know that hydrogen has one electron, so overlap with this one hydrogen, and here another hydrogen come and overlap with this, and another hydrogen come and overlap with this, and another hydrogen come overlap with this. So all are hydrogen. So in that case you can think it is a methane molecule, and this shape is called tetrahedral shape. So in case of sp3 hybridization, the all three bond will be like this, and one will be top, and that shape is called tetrahedral, and each angle is like 109.28 like degree. So if I want to show you how it looks like, so this is the tetrahedral shape. So each bond has 109.28 degree from here, from here, from here, and also any rotation you do, it will show like same. So this is called tetrahedral shape. So you can see that this tetrahedral shape. Now if you attach a hydrogen in it, so you can see the methane molecule. So this is the methane molecule. So any side you rotate, you will see the same rotation. So this is called sp3 hybridization, and this is the methane molecule. So this is carbon, and this bond is formed sp3, and actually hydrogen is giving s orbital, so that's why it's called sp3s orbital. Like if I want to say, so this is sp3s, and here sp3s, sp3s new bond, sp3s bond. So if anyone asks like what kind of hybridization or bond are present in this methane molecule, so you can say sp3s, 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 sp3s. So total 4 sp3s in the methane molecule, and all of them angle between like two bond is 109 degree, 109.28 degree. So if you see this molecule, so any direction you rotate this molecule, so it will rotate, it will put three different area, and one will be on the top, so all will be the same, so all angle are same. So this is like sp3 hybridization. I think you will you understand the part of the sp3 hybridization.